Now that we described the possible DSM architecture, I'd like to comment on its possible implementation. One thing to consider when implementing a distributed shared memory system is that the distributed shared memory layer has to intercept every single access to that shared state. This is needed in order to detect whether the access is local or remote, and then trigger remote messages requesting access if that's necessary, or to detect that somebody is performing an update operation to a locally controlled portion of the distributed shared memory, and then to trigger any necessary coherence messages. These overheads should be avoided whenever we're trying to just access local non-shared pages or non-shared state. So what we would like to achieve is an implementation where it is possible to dynamically engage whether the distributed shared memory layer will be triggered and will be intercepting any accesses to memory in order to determine what to do about them, or disengage the distributed shared memory layer if we're performing access to pages which are really not shared and are just local pages accessed on a particular node. To achieve this, a DSM implementation can leverage the hardware support that's available at the memory management unit level. As we explained earlier, if the hardware MMU doesn't find a valid mapping for a particular virtual address in the page table, it will trap into the operating system. And similarly, the hardware will also cause a trap if it's detected that there is an attempt to modify a page that has been protected for write operations, a write protected page. We can leverage this mechanism to implement a DSM system. Whenever we need to perform an access to a remote memory, there will not be a valid mapping from the local virtual address to the remote physical address. The hardware will generate a trap in that case, and at that point, the operating system will detect what is the reason for that trap, will pass that page information to the DSM layer, and the DSM layer will send the message. Similarly, whenever content is cached on a particular node, the DSM layer will ensure that that content is write protected, and that will cause a trap if anybody tries to modify that content that will turn control over to the operating system. The operating system can pass the relevant information to the DSM module, and then that one will trigger all of the necessary coherence operations. When implementing a DSM system, it is also useful perhaps to leverage additional information that's also maintained by the existing memory management that the operating system and the underlying hardware provide. For instance, we can track information like whether a page is dirty, we can track information whether a page has been accessed in the first place, and this can let us implement different coherence mechanisms and consistency policies. For an object-based distributed shared memory system that's implemented at the level of the programming language runtime, the implementation can consider similar types of mechanisms that leverage the underlying operating system services. Or as an alternative, everything can be done completely in software with support from the compiler, so tracking whether a particular object reference is remote or local, or whether an object is going to be modified or not. We can make sure that we generate code that will perform those checks on every single object reference.